Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video, we have seen how to use standard Hough transform using HoughLines method in OpenCV. Now in this video, we are going to see how to use probabilistic Hough Line Transform using a method called HoughLines method in OpenCV. So let's go to our editor, and this was the code we have written last time, and we have used HoughLines method for detecting lines inside this image, which was the Sudoku image. So let's run this example really fast to see what was the result which we got last time. So this was the result which we got last time, and the problem with this result is you can see these lines just go from one end to the other end, and in this kind of Hough transform you will be able to see that even for the lines which have two arguments, it takes a lot of computation. So in OpenCV there is also a method called HoughLines which stands for Probabilistic Hough Lines Transform, and this Probabilistic Hough Line Transform is an optimization of the normal Hough transform which we have seen in the last video. So let me close this example and let's open the example which we are going to see in this video. And you can see in this example we have used this HoughLines P method. So when we use this HoughLines P method, it doesn't take all the points into consideration. Instead, it takes only the random subset of the points which is sufficient for the line detection. So let's go through this code from the top to the end. So as you can see, I have imported these two packages, cv2 and numpy as np, and then I'm reading this image Sudoku using imRead method, and then I'm converting this image to the grayscale image using cvt color method in cv2. Now the next step is to find out the edges of the images. This we have also seen in the last video. So until here everything is same. So once we got the edge detected image using Kenny edge detection, instead of using the HoughLines method, we are now using this HoughLines P method, and it takes few arguments. The first argument is your edge detected image. The second argument is the row, which is the distance resolution of the accumulator in pixels. The third argument is the theta value, which we have taken np.pi divided by 180, which is the angle resolution of the accumulator in radians. The next value is the threshold. So right now we have taken this threshold as 100, and this threshold is the accumulator threshold parameter, which means that only those lines are returned that get enough vote, that means greater than the threshold value. The extra two arguments here are a little bit different from the HoughLines method. So you can see all these arguments are almost same, these four arguments, but there are two extra arguments here or parameter here which we need to provide. So the first parameter here is the minLineLength, and this we have taken 100. So this minLineLength is the minimum length of the line, which means that line segments shorter than this length, which is 100 in our case, will be rejected. The next argument is the maximum line gap, and it is the maximum allowed gap between the line segments to treat them as a single line. So these are the two extra arguments we have taken, and this HoughLines P method is going to return again the output vector of the lines, but the difference between this return value from HoughLine P method and the HoughLines method is you can see here this line at index 0 is going to directly give you the values of x1, y1 and x2, y2, which are the 2 points which we will be able to join, and we will be able to draw the line using cv.HoughLine method. In the last video, I have shown you that you have to do so much calculation in order to find this x1, y1 and x2, y2, and this probabilistic Hough line transform method is going to do our job easy, and it's going to directly give us these 4 values, so you don't need to do anything. You just need to pass these x1, y1 and x2, y2 value to the cv.HoughLine method. So cv.HoughLine method is going to take the first argument, which is the image, and then the second argument is the point 1 coordinate, which is x1 and y1, which we got from the line variable at index 0, and the third parameter here is the point 2, which are the coordinate of the point 2, which is here x2 and y2. The next argument here is the color, which we have taken right now 0, 2, 55, 0, and the last parameter here is the thickness of the line, so we have taken 2 here. And the next 3 lines are going to just show this image. First of all these lines which we found out are drawn on the image, this image which is the original image, and then we are just showing this image after drawing all the lines which we got using HoughLines P method on the original image, and then we are just loading this image using this ImShow method, and then after we are done, we are just destroying all the windows. So let's see what result we get after this script is run. So I'm going to run this script, and this is the canny edge detected image, and this is the image you got when you apply this HoughLinesP method on your canny edge detected image. So you can see these lines are no longer going to the end to end. These are more accurately detecting all the lines which are there in this Sudoku image. You can see some lines are broken here, so that's why these lines are not even drawn, because they are not even detected by canny edge detection. So this one or this one are not detected by canny edge detection, so that's why these lines are not drawn. So let me show you these results side by side. So this was the result which we got after applying the Hough line transform method, which is HoughLines, on our canny edge detected image, and you can see all these lines here, and this is the result which we got after applying HoughLinesP method, which is the probabilistic Hough line transform. So these 2 methods are available in OpenCV to detect these lines in an image. Now let's go back to our script, and here instead of this image, which is the sudoku.png image, I have one more image which is called road.jpg, and this is the image which contains a road, and inside this road we have some lane lines. So you can see this result now here, which is the road, and these are the lane lines which are detected using this HoughLinesP method. So in case of lane line detection, you can use this HoughLinesP method, but you need to decide your ROI or region of interest, because you can see some lines are detected here, 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 and here. So you just need to define your line of interest region, and you will be able to detect all the lines or lane lines on the road. So maybe in the next video we are going to see how we can detect these lane lines on the road accurately without these noises which we are seeing here on the other part of the image. So we just need to detect these lane lines and nothing more, and we will do the same on our video. So on the video in which these lane lines are there, and we just need to continuously detect these lane lines. So in the case of, let's say, self-driving car, you need to detect these lane lines. We are going to see how to detect these lane lines. So that's it for this video. I will see you in the next video.